because when we mention technology, we want to think in terms of its life cycle. That's not really unique on my part, frankly. If you were to go to the Environmental Protection Agency's website and look at some of their environmental impact statements, you would see that they talk life cycle a little bit. And if we were looking at energy accounting, that would be true too. If you wanted to say, well, gee, here's a box of cereal. Well, there's energy content in that cereal because, the farmer had to till the fields, he had to plant the seed, he had to harvest the grain had to be stored and transported, and it just goes on and on. It gets processed, and it gets boxed, and it gets transported to the store, and it's on the shelf, and you get it. And there's so much energy involved in producing that box of cereal. Well, we won't get into that kind of detail, but I want you to be aware of it. And so the idea of thinking of a technology in terms of its life cycle is important. Now, I thought, well, what might we use as an example to get into more than just words, so you have a better concept of what this involves? And so I'm going to look at electric energy generation, and I'm going to do that in terms of an energy use or flow diagram for the United States for the year 2012. And as you can see, you've got that in front of you. And you could, in every country, every village, every home, you could make a very similar diagram if you had this wherewithal to do that in the time. For the United States and maybe for some other countries, but for our country here, you could go to the Energy Information Center. If you put that into Google, you'll end up there. And it's a part of the United States government, and their whole reason for being is to maintain data sets of energy production, use, and acquisition, whether it's solar or whatever. So this diagram, which was made, as you can see, by Lawrence Radiation Laboratories, by the way, one of the federal laboratories that's in the United States, and that being tax supported in this country, you can call them up, you can go to their website. All that information is available to the public except that which is classified for national security reasons, like might be the case at Los Alamos Laboratory in New Mexico. But we'll talk more about that again when we talk about information acquisition to enhance your awareness. But let's look at electric production. Electricity production is done with technologies, and we're going to look at the use of steam turbines. For those that are engineering types, it's the Rankine cycle. And in this diagram, you'll notice that they use quads, which of course is, it's hundreds, thousands, millions, billions, trillions, quadrillions. So you can see that's a big number. And that's in terms of British thermal units or BTUs. Doesn't matter so much what the number is. In looking at this diagram, what's important is the relative amounts. Okay, so we're going to look at electric energy generation. What do we notice? Well, golly, it turns out that almost everything on the left-hand side of this diagram, which is our energy resources to feed into the electric generating system. If you don't have to burn it, then there's no Rankine cycle, there's no steam turbine. For example, up at the top, you'll notice that in 2012, a little bit of solar went into the electrical grid in the United States and was used by basically some businesses, some homeowners, and that sort of thing. The United States solar use is increasing, and there's countries in Europe which are much more heavily engaged in that than we are at the present. Let's take a look. We've got solar, we've got nuclear, and gee whiz, nuclear is kind of the red line. The relative thickness or width of that line is an indication of quantity. So the wider the line, the thicker the line, the more of that resource. Well, let's just look at nuclear. If we're going to talk about electric generation with nuclear, we have to go, and we're doing the life cycle thing, we have to go back to looking at the mining of the uranium. The mining of the uranium, the processing of the uranium ore, because that's what you're mining is uranium ore, that has to be processed, that has to be, and that involves enrichment, that involves transportation and by safe means because of the issues of radiation exposure, not only by ingestion, inhaling, and just being in the vicinity of radiation, because like light waves, it passes through the atmosphere and will impact on you. Unless you're properly shielded, it will impact on your body, and it will penetrate your body. So there's lots of things to think about when you're thinking about nuclear electrical generation. And you might ask the question, well, how does that relate to ethics? Well, the fact of the matter is, you have to think about, well, we're using the uranium to make electricity, and there's some miners out there getting that. Are they working in a proper environment? Are we making sure that they're as safe as we are by using the end result of that electric production? So you see, the ethic thing isn't just with the reactor. It's with everything associated with it, because nuclear energy is even different than anything else, because you take the fuel out, there's things still in that fuel that can be used, plutonium for weapons or other reactors, radioactive substances that are going to last for hundreds and thousands of years. And so we can reprocess it, take out the good stuff and try to reuse it. We can bury it, we can store it until it decays away. I mean, there's all sorts of things, and there's a whole thing called the nuclear fuel cycle which involves all this, and at each step of that we have to think about how's that affecting our culture, and how is that and as a consequence, how is that affecting each and every one of us now, not only now, but in the future. And if you're going to stand up and want to change something that's moving forward as much as it is, like, say, any of these items on the left-hand side here of this diagram, you're going to find people that oppose you. And you'll find people that'll be on your side. And that's going to require a lot of inner directedness on your part, because you're going to stand up for your ethic as to what you think is the right thing to be doing. And that's why I keep saying over and over and over, in this course, the ethic is what yours is, and how strong is your belief in that? It isn't some intellectual thing, well, Plato says, or the church leaders say. It's what you believe and will do in the face of difficulty. But anyway, enough of that. So that's the idea behind the life cycle, and the same thing we could say about coal, Coal is mined. Turns out that a lot of people die because of coal mining. And it's a very dangerous business. And then there's the shipment of the coal, and we'll be talking about that later. And then there's the result of the coal being burned, because it produces, just like if I'm burning natural gas or I'm burning alcohol or whatever I'm burning, I am putting carbon dioxide and moisture in the air because the consequences of burning an organic substance. That's a substance with a lot of carbons and hydrogens. It's like what we're made of. You always get water and carbon dioxide, among other things, out of that. So it's the carbon dioxide that seems to be the problem relative to what's happening in our atmosphere. So that in itself creates an ethical issue, doesn't it? And near the end of our time together, we're going to look at a report put up by the United Nations on the ethics of this global climate change. That kind of relates to this life cycle thing, doesn't it? Well, let's see what they use. They use petroleum. There's biomass. Biomass could be biodiesel. If you're running a diesel engine and you make biodiesel, you can make it from any vegetable oil. Quite a few years now, people have been using the used oils from restaurants, the used cooking oils, processing it and turning it into biodiesel to run in trucks. I can remember when they first were doing it, a truck or a bus would come by here in Columbus that was using it, and it smelled like French fries. Then, of course, there's coal, natural gas, and you can see the coal and natural gas and nuclear play a pretty big role in electric production. There's geothermal. Well, what's geothermal? Because that's an interesting one. It's not totally devoid of impacts. What it is we know that the internal part of the Earth is molten. That's why we have volcanoes, right? And some of that molten material, magma, is close to the surface of the Earth. Now, if it's close to the surface of the Earth and there's a water table nearby, or there's water underground in a lake or a stream or whatever, it can be heated and turned into steam, which if you, say, ran a pipe down there, you could pick up that hot water and use it to boil more water or flash it into steam and run it through a turbine and make electricity. And then the question is, well, what do we do with the material when we're done with it? Well, you wouldn't quite go through that process because it's very corrosive, and it's something you don't want to put on the ground because it'll keep crops from growing. So what you do, and I saw this in the Philippines when I was there visiting a geothermal plant, the material is you take what you want, but then you pump it right back down into the earth so it doesn't contaminate the surface. And there are geothermal possibilities here in the United States, particularly in Southern California. Wind is gaining popularity. If you were to drive down the highways in some parts of Ohio and Indiana, just for example here in the Midwest, you'd see wind farms. Large windmills generating electricity when the wind blows, and it's turning out to be a non-polluting, but then again, it's got its problems too, because people are worried about birds being killed and its impact on the animal ecosystem, you might say, in our country as well. Hydroelectric, well, you can build a dam, create a lake, run the water through a turbine because you're taking advantage of the energy that's released as water falls from a height down to a lower level. And but when you build a dam, create a lake, you change the ecosystem, and people that are concerned about impacts on nature as contrasted to impacts on the economy or whatever, they're concerned about that. So there's the building of the dam and the workers who are building the dam and the impacts of how that affects people that were living in that area right here in Columbus area, Columbus, Ohio, where Ohio State is. We have some man-made reservoirs or lakes. which were built for flood control, and there's one outside of town, and we have some relatives who used to live in a little town that's now at the bottom of that lake. So you have to think about that stuff. So it isn't just, oh, well, we got a dam here, and the water's coming through the turbine, and we're making electricity. We have to think about what was required to do that and its impact, not only on our community, but on the people that live there. Now, interestingly enough, the people had to move out so their town could be flooded. Land that was used for agriculture or trees or whatever is gone. And the property surrounding that lake value has gone way up because everybody likes to live near a lake. So there's all kinds of impacts, and you got to ask the question, what's ethically okay and what isn't, and that depends on your value system, doesn't it? So so we've been talking about the stuff on the left here, and the electric generation, and we notice that there's a yellow line leaving the generator, which is the electricity, and there's a gray line leaving there as well, and that's the waste products. That's the energy that's lost out the smokestack, you might say. And if you just look at the ratios of how much these numbers that went in and to the number that's in the yellow, you'll see that, it's not even 50% efficient. It's less. It's around 40, maybe even less than that. So, you're using that product, so what's it doing in the residential area and the commercial area and the industrial area? And there's a little tiny yellow line coming down here in the transportation. Now people are saying, well, let's have hybrid cars, let's have electric cars, because they don't have an exhaust, and it'll be cheaper too, because electricity is cheaper than a gasoline or diesel fuel. So that's what we're going to do. And we won't be as polluting. Well, is that true? Because if we're looking at the life cycle of that technology, we notice that there's a lot of waste gas, exhaust gas, coming out of the power plant that makes the electricity that's going to run your car. Now, somebody could say, use solar power. Okay, then you don't have that. Or let's use nuclear, because you go by a nuclear plant, you don't see anything but a building. They don't even burn waste paper there. So that's not as polluting. But then again, back in the early stages where you're getting your raw materials and the like, you have to think about that and the nuclear fuel cycle and all the things that entailed. So life cycle of the technology is important, because and I hope I'm making my point, that at each aspect of bringing that technology into being, using it, and then disposing of it, humans are involved, infrastructure is involved, economy is involved, and that affects the culture. And are there ethical issues there? Well, if you're aware and you've done some analysis, you should know. So I hope that just spending some time on this energy diagram has done several things. One is that it's given you some idea as to how energy moves through a society, in this case, the United States. Hopefully, it's given you an idea of all the different technologies that are available to supply that electricity and how we have to think about impacts on the life cycle of each one of these technologies, whether it's coal mining. You see, if coal mining is, we don't think about the person that's suffering as a coal miner or existing as a coal miner and some of the difficulties they have when we're sitting under our electric lights watching TV in an air-conditioned room, drinking a drink that just came out of a refrigerator. So it was cool. So we have to think about that. And then you say, well, gee whiz, what do we do about it? Is it right that these people have to work in that kind of environment? Well, if they elect to work in it, hey, that's their problem, not mine. So what? On the other hand, you may say, well, we tell people not to smoke because it's not good. We tell people to wear seatbelts in case they get in an accident, even though they may not want to. So maybe we should be developing some technologies to make their lives safer. And if you don't believe what I'm saying, contact the local insurance company and get some mortality tables that relate to number of people that die per thousand or whatever scale they use, and you'll find that mining is one of the higher numbers. Well, that's all I wanted to say at this point in time to get us thinking and understanding when I use the word technology that this is how I'm thinking, and hopefully as a consequence of this is what you're thinking. So the next issue we're going to look at is, what do we mean by culture?